Yeah, good day to you. You are welcome to Linear Stereo Collect class. And the question I will have here is, show that y equals to 2x plus c exponential x is the primitive of the differential equation dy dx minus y equals to 2 open bracket 1 minus x, and find the particular solution satisfied by x equals to 0 and y equals to 3. So now if you are given a question like this, so let's start with this particular solution. To obtain particular solution is the one we obtain this one by assigning a definite value to the essential arbitrary constant. To obtain the particular solution, we obtain it from the primitive. Now we're going to use the values given here. That's x equals to 0 and y equals to 3. So without the differential equation, we can still obtain the particular solution. We'll just go to this particular place where we see x will put 0, then anywhere we see y will put 3, and we'll see that the value of c will be equal to 3. But let's start with this particular one to show that y equals to 2x plus c exponential x is the primitive. So now let's go to the solution. So now the primitive that we have there is y equals to 2x plus c exponential x. We make this one equation 1. So this is equation 1 and this is the primitive. So this is the primitive and that's equation 1. And don't forget that the number of constant that we have there will tell us the number of times that we differentiate it. So here we only have a constant, and what we have here, we have dy dx minus y equals to, so the next one will be dy over dx minus y equals to 2 into 1 minus x. So this one is the differential equation. So here we have equation 2. This is the differential equation DE. So we can use D to denote that one. So this is the differential equation, the one that has no constant, that's the differential equation, and the one that is having the constant, that's the primitive. So now let's find dy dx, then we'll subtract it from y, then let's see, maybe this side will be equal to the other side. So now dy over dx is equals to, so differentiating 2x with respect to x, that will give us 2 plus differentiating c exponential x with respect to x, that will give us c exponential x. So we'll make this one equation 3. So this is the third equation. Now don't forget, when you go back to equation 2, here we have the y dx minus y. They ask us to show that this y equals to 2x plus c exponential is the primitive of this differential equation. And for this one to be the primitive of this differential equation, we need to subtract this from this. That will contain 2 into 1 minus x. So now, we'll now substitute, put equation, so we have equations, that's 3 and equation 1 into equation 2. So we're going to substitute equation 3 and 1 into equation 2. And from equation 2, we have y, and that is what we have in equation 1. And again, we have the y dx, and that's what we have in equation 3. So don't forget that from equation 2, we have the y dx minus y is equal to 2, open bracket 1 minus x. So that's what we have from equation 2. And the value of the y dx is 2 plus c exponential x. We put this one in the bracket minus. The value of y is 2x plus c exponential x equals to 2 into 1 minus x. So now let's simplify this side. Maybe we'll obtain the other side. So here we have the left hand side and we also have the right hand side. So now so simplifying this, we have 2 plus c exponential x minus 2x minus c exponential x equals to 2 into 1 minus x. So from here, we need to collect the like terms. And don't forget that here we have cancellation log here. Plus c exponential x will cancel minus c exponential x. So here we're going to have 2 minus 2x equals to 2 into 1 minus x. And the next thing I will do here is we'll collect the like terms from the right and from the left hand side. 2 is common here. We have 2 into 1 minus x equals to 2 into 1 minus x. So you can see that this side, we have the left hand side is equivalent to the right hand side. So therefore, the comment will now be y equals to, so therefore, y equals to 2x plus c exponential x is the primitive, is the primitive of the differential equation dy over dx minus y equals to 2 into 1 minus x. Because the left hand side is equal to the right hand side, that means y equals to 2x plus c exponential x is the primitive of the differential equation. And don't forget, the last question I will have here is we are asked to find the particular solution. So now to obtain the particular solution, so here we have the particular solution. And to obtain this, we'll go to the primitive. So the primitive is equal, that's y equals to 2x plus c exponential x. So this is the primitive. And don't forget that the point is at point, the value of x is the first one, that's 0. Then the value of y is 3. So x is equals to 0 and y equals to 3. So we'll go to the primitive. Anywhere we see y, we'll put 3. And wherever we see x, we are putting 0. So plus c exponential 0, we have 3 equals to 0 plus c. N raised power 1 is, n raised power 0 is 1. So exponential 0 is 1. So here we have 3 equals to c. So this implies that c equals to 3. So therefore, the particular solution, the particular solution is y equals to 2x plus, we'll go back to this particular, and we'll go back to the primitive. So let's go back to this primitive. So and the value of c is equal to 3. So instead of writing c, we're going to write 3 exponential x. So this is a particular solution. So if you have to obtain a particular solution, you go to the primitive. The values, that is the point given for x and y, that is what we'll just substitute to obtain the particular solution. Then whatever value we obtain for the constant, we'll go to the primitive, we'll substitute to get the final answer. Thanks for watching. Kindly like, share, and subscribe.